In exercise 1b, we will now apply the bootstrap. We will calculate the bootstrap mean of the target variable g1 from the student's math dataset from last session, and then describe the results and calculate the confidence intervals. So first we will install the packages, so the package boot, and then import it. So next we will import the student maths dataset using the separator semicolon and store it in df, and then delete G2 and G3 for later. Now we will save our target variable inside X, so it's easier to handle for this operation now. Then we have to define the mean function, and we cannot use the built-in mean function because the boot function requires a slight variation, as you can see here. So I need to define this function that takes these two inputs, x and d, and then returns the mean of the inputs. So the first part is the variable, and the second part is the index. And we need to specify it this way so the boot function can actually use this function. We set seed, I set seed to 1, but we set seed in general, so you can replicate this, and as you can imagine, the random sampling in the bootstrap samples could vary, so you would get different results. So to replicate this, just use the same seed. Now the input x is our target variable. Then the mean function is the function we defined before here. Then r is actually our parameter capital B that I explained in the previous exercise. We set it to 100, so there will be 100 bootstrap samples. And setting sim to ordinary will just tell the function that we will use the ordinary bootstrapping as we discussed before. So let's run the cell. Now first I need to define the function and then run the cell. And now we get the statistics. So original is the mean of the original data set, so not our bootstrap mean. I can show you this in this cell below. So you see these values are roughly identical. Bias is the deviation of the bootstrap mean from the original mean. So the bias describes how much the bootstrap mean differs from the original. That means that the bootstrap mean is the sum of the original and the bias. And as the bias is negative, here is a minus, so don't get confused, it's the sum. So this would be our bootstrap mean. We can also have a look at all the bootstraps sample means. So these are those. So you see that there are slight variations, but they're roughly equal. So this would be what we expect. And now if we take the mean of this, we would get the bootstrap mean. And we can see that it is the same as the original plus the bias. Now to calculate the confidence intervals, we use boot.ci, and the inputs of the function is our statistics that we calculated before. And then we can define the types, and I use the types from the lecture. So we can see the intervals here, and I described the different types of these confidence intervals below. So the normal, which is this parameter here, normal interval calculates the confidence intervals using the normal approximation with a bias correction. Then the percent confidence interval shows the respective percentiles, as we also did in the first part of this exercise by hand. Then the basic will calculate the intervals using the difference between the mean of the whole data set and the predictives and the percentiles. I won't go into details how this works in detail, but if you want to have a closer look, then you can always go and have a look at the official instructions you can find under this link here. And that was it for this exercise.